Okay, let's just dive right in, because today we're on a real mathematical quest. We're going to venture into this, well, strange and beautiful corner of fractal science to crack a series of mysteries that have been lingering for a while. And yep, you're seeing that right. Alien calculus. I know it sounds like science fiction, but I promise you it's a very real and very powerful field of mathematics. And, it's actually one of the main clues in this whole mystery we're about to unfold together. See, the thing is, what we're talking about today isn't some single, isolated discovery. Nope. It's more like the latest chapter in this ongoing scientific saga. We're talking about a whole series of research papers where each one builds directly on the one that came before it. So here's how the story goes. You have paper 10, which laid all the groundwork. Then came paper 11, and it used that foundation to ask three really critical questions. And the one we're digging into today, paper 12, well, that's the one that answers them. And in doing so, it kind of paves the way for the next big thing in paper 13. And honestly, this is just a perfect example of how modern research works, right? It's like a relay race of knowledge. The finish line for one team is the starting block for the next. So today, we're looking at the paper that grabbed that baton and just ran with it, solving the problems its predecessor couldn't quite crack. All right, so let's set the scene. The paper right before this one, paper 11, it did some absolutely groundbreaking work. I mean, they calculated a key value to 5 significant figures. But it ended on this massive cliffhanger. It left the whole scientific community with 3 huge, unanswered questions. So these were the 3 open problems. And you can totally think of them as 3 locked doors. First, what's the sign of this key value? Simple question, right? Second, what's the hidden or alien structure of a particular series? And third, can we actually find a perfect formula for another crucial measurement? Well, guess what? Paper 12 has the keys. Okay, so first up, the researchers went straight for that mystery of the sign. Now, I know, what's the sign? Sounds super simple, but trust me, figuring out a fundamental property like that for a mathematical constant can be one of the most challenging and important steps in any proof. So, get this. After all the incredibly complex calculations in that previous paper, they still didn't know if the answer was positive or negative. A simple plus or minus sign. That's what was standing in the way of a much deeper understanding. So yeah, how do you even solve something like that? Well, you pull out a very specific tool from the toolbox. In this case, it's something called Picard-Lefschetz analysis. The best way to think about it is like a special kind of geometric compass. It lets mathematicians map out these unseen, really complex territories and figure out their fundamental properties, like which way they're oriented. And after using this incredible tool, they found their answer. The sign of the Stokes constant, which is this key value that describes behavior in certain complex systems, is -1. Just -1. A beautifully simple, totally definitive answer. And just like that, the first door was unlocked. All right, on to the second mystery. And I know this is the one we've all been waiting for. This is where we finally get to talk about alien calculus and how it helps reveal a much, much deeper understanding of these mathematical patterns. So what is alien calculus anyway? It totally sounds like something from another planet, right? And in a way, it kind of is. It's a method for seeing things that are, for all intents and purposes, invisible. It's actually named after the mathematician Jean Écalle. And the reason it's called alien is because it uncovers structures and rules that are completely foreign, or, well, alien, to the original problem you're looking at. It's like it reveals the secret DNA of an equation. See, the whole reason you need this alien perspective is that the rules governing these patterns are totally invisible with standard methods. You just can't see them. So by applying this calculus, the researchers finally identified that hidden structure for a specific pattern, something called a Class B series. It's like they found its secret rulebook. And boom, the second door was unlocked. And now for our third and final mystery. What's so interesting here is that the solution, well, it wasn't a final answer. It was something that's arguably even more powerful, a brand new, incredibly precise starting point for all the research that's going to come next. So the challenge was this. Could they create a kind of mathematical recipe, a perfect blueprint for the absolute value of that Stokes constant? They needed a precise analytical formula that would define it perfectly. But here's the twist. Instead of a final proof, the paper gives us something just as valuable, a new conjecture. Now, in math, a strong conjecture is a huge leap forward. It's basically a clear, evidence-based, testable hypothesis. It's like the researchers are telling the entire field, look, here, we are almost certain this is the answer. Now, let's all work together to prove it. And they built this really powerful conjecture using yet another specialized technique. This tool let them define the value with just incredible precision, which basically sets up a crystal clear, accurate target for that final proof that's still to come. So wow, after that incredible journey, where does that leave us? Well, Paper 12 totally answered the call from Paper 11. It solved its 3 biggest mysteries, and in the process, it blew open a whole new frontier. So let's just quickly recap the wins, right? 1, they proved the sign of the Stokes constant is -1. 2, they identified the hidden alien structure that governs the series. And 3, they established a powerful new conjecture for that formula. 3 problems posed, 3 major advances made. Not bad at all. And that right there brings us to the edge of our current map. The work in Paper 12 has given us a clear target for Paper 13 and whatever comes after. The new open problem, the main quest for the next chapter, is to go out and prove that this conjecture is true. Because the quest for knowledge, it never really ends, does it? It just gets to a new and, honestly, way more interesting level.